The exercise files for this course are mostly console applications. That means that they display output as text on a console and take input from the keyboard. The console may look different on different systems. In the terminology of the C++ standard library, the standard output stream is how text is displayed on the console. There are several ways to send output to the standard output stream. So far in this chapter, we've used the puts and printf functions. C++ also has an object-oriented class for displaying output on the console. The stdout class is part of the standard C++ library, and it works quite a bit differently than puts or printf. In fact, it works quite a bit differently from other objects and classes in C++. So here in Xcode, I've opened a working copy of hello-cout.cpp. And the first thing you'll notice is that my include statement on line 2 includes a library called iostream rather than the cstdio that I've been using in the rest of the chapter. The iostream library includes cout. Cout is a class that overloads the bitwise left shift operator to send a stream of characters to the standard output stream. It's very common in C++, and you'll see it used a lot. So here we have this statement with cout, and that's the name of the class, and the bitwise left shift operator is used to send a stream of characters to cout. And so it kind of looks like a left arrow, although it really is the bitwise left shift operator. So when I build and run this, you'll notice that it displays hello world. I'm sending two different things to cout here. I'm sending this hello world, and I'm also sending this other class called endl, which is simply a class that sends an end line, and it's commonly used with cout like this. You can string different arguments together like this. So let me put a space after hello world here, and I can say 2 times 7 like that. And when I save and build and run, you'll see it says hello world and the number 14. And I could even put in another string here. I'll put a space at the beginning of it, and I'll say another string, and save and build and run, and now it says hello world 14 and another string. So this looks pretty convenient, and in fact it is pretty convenient. It's also a little bit clever the way that it overloads that operator. If you have some experience in C++, you've probably noticed that I often use puts or printf instead of cout, and there's a reason for this. So cout is another approach to the same problem. So how do I choose which one? Some people maintain that cout should be preferred because it's more object-oriented than puts, and I tend to disagree with this opinion. From a purely language standpoint, while cout is certainly a class, it's not used in the traditional object-oriented way. In fact, it's rarely even used to create an instance of an object. Instead, it's used as its class by overloading this bitwise left shift operator to do something that actually has nothing to do with shifting bits. This is very clever, but personally, I don't like to overload operators in a way that redefines their meaning. When I see an operator, I want to know what that operator does. The bitwise left shift operator is supposed to shift bits. By redefining its meaning to send a stream of characters to the console, it makes the code more confusing, not more clear. And now I need to look at this operator more closely everywhere because a lot of classes overload it to support cout instead of shifting bits. I find this messy. Of course, this is just a semantic argument and many people don't agree with me, and that's fine. But I'd like to give you a more technical explanation as well. So we're going to compile some code on a Unix server. And I'm doing this because this is a compiler that supports static libraries, so we can see more clearly the impact of this code. So here I am logged into a Unix server. It's a virtual server that I rent from a cloud company. And you notice that I have these 3 C++ files. So hello.cout is the one that we just saw. And it looks like that. It's exactly the same code that we have here in Xcode. And I also have one called hello.puts. And it's the one that we've been using the rest of the course, and it uses puts to display hello world. And I also have one with printf, which is another common way to do this. And you'll see a lot of people do it this way with printf instead of puts. Now I'm going to compile them, and I'm going to compile them with static libraries. And the reason I'm doing that is so we can see how big the code actually is. Most compilers by default, they use shared libraries. So they're using code that's shared in the rest of the system. So you don't actually get to see how much code is being built into the program because a lot of it's hidden in this shared library. But this will allow us to see this. So I'm going to say -o hello-puts and hello-puts.cpp. So that'll compile it. When we look at it, we see this hello puts down here and the size of the object file that it is created by compiling it. And this is actually everything that it needs to run the code. And in fact, I can run this like this, and it says hello world. Now I'm going to do the same thing with the printf version. And when we look at our output, we see that the printf version is pretty much the same size as the puts version. It's just a few bytes different. It's almost indistinguishable. Now we'll do the same thing with the cout version. Now you'll notice that the cout version here is about twice as big as the printf version or the puts version. And that's because in order for it to do this cout thing that it does, it has to bring in a whole lot of the STL library just to support how it works. So displaying something on the console is actually a pretty simple operation for the library to do. And it doesn't really necessarily require all of this other support. In fact, all of this other support is just to create this syntactic anomaly by using the left shift operator instead of a pair of quotes and a string. C++ is often used for system programming and other large projects where every bit of performance and sometimes every bit of memory space is vitally important. So as a programmer, I tend to be conscious of how much a bit of code costs in terms of performance and memory space. And this is really part of what being a system programmer's job is. So it's important to understand how cout works, and I'll cover it in much more detail later in the course. It's also important to understand the impact of your library choices. Using existing libraries always means trade-offs, usually trade-offs between convenience and performance. A general purpose library like the C++ standard library is often very convenient, but it's not always efficient.